In this very lesson, we shall be looking at this particular question on the board. Remember, we are still on the same topic, probability, and we are looking at how we can solve questions on compound experiments. Can you like, share, and subscribe to this very channel for more exciting episodes to come? So with the question, it says that a fair coin is tossed twice and a die is tossed once. We want to find the probability of obtaining all of these events. A fair coin is tossed twice and a die is also tossed once. This is a compound experiment. So the first thing that we are to do is to write down all the set of possible outcomes for this experiment. We are saying that a fair coin is tossed twice. So when a coin is tossed twice, what are all the set of possible outcomes for that experiment? So when a fair coin is tossed twice, we can have this head-head. We can also have head-tail. We can have tail-head. And then we can also have tail-tail. So these are all the set of possible outcomes when a coin is tossed twice. Also, when a die is tossed once, what are the set of possible outcomes for that? So when a die is tossed once, we can either get the number 1, 2, 3, 4, 5, or 6. So these are the sets of possible outcomes when a die is tossed once, and these are all the set of possible outcomes when a coin is tossed twice. When we combine these two experiments together, it becomes a compound experiment. So how do you write the sample space for these two experiments? We can use the table approach, so that is what we are going to draw. We are going to use this column to represent the set of possible outcomes when a coin is tossed twice. So we have head-head, head-tail, tail-head, and then tail-tail. And then we'll be using this rule to represent all the set of possible outcomes when a die is tossed once. So we have a die and then a coin. So we have 1, 2, 3, 4, 5, and then 6. So what we'll be doing here is to pair the outcome from the toss of the coin with the outcome from the toss of the die. So we have head, head 1, head, head 2, head, head 3, and so on, or in that order. So we have head, head, and then 1. There we have head, head, and then the number 2, head, head, and then the number 3, head, head, and then the number 4, head, head, and then the number 5, and then we have head, head, and then the number 6. We are going to repeat the same process, head, tail, and then the number 1, head, tail, and then the number 1, head, tail, and then the number 2, head, tail, and then the number 3, head, tail, and then the number 4, head, tail, the number 5, head, tail, and then the number 6. Then move on to this, we have tail, head, and then the number 1, tail, head, and then the number 1, tail, head, and then the number 2, tail, head, the number 3, tail, head, the number 4, tail, head, the number 5, tail, head, and then the number 6. Then move on to the last one, tail, tail, the number 1, 2, the number 2, 2, the number 3, 2, the number 4, 2, the number 5, and 2, the number 6. So these are all the set of possible outcomes when a fair coin is tossed twice and then a die is also tossed once. Now, all these outcomes in this arena, this arena becomes all the set of possible outcomes when a fair coin tossed twice and a die is also tossed once. So these are the set of possible outcomes. You can write them down or you can leave it in this form. So once we are done with all the set of possible outcomes, we find the number of outcomes in the sample space. So it means we have to count all of these outcomes one after the other. So we have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 6 times 4 will give us what? 24. So there are 24 outcomes in this sample space. You can count them one after the other, and you are going to get 24. Then move on to probability of obtaining 2 heads and then a 5. So let's use the letter H to denote the event of obtaining 2 heads and then 5. So first we have to list the outcome in this event. So let's look through the sample space to see if we can have 2 heads and then the number 5. So this is the 2 heads column. We have the number 5, this is the number 5. So we are going to have 2 heads and then a 5. Then we move on to find the number of outcomes in that event. We have how many outcomes? We have only 1. From here, we can proceed to find the probability of obtaining 2 heads and then a 5. So we have a number of outcomes in that event all over the number of outcomes in the sample space. So we have 1 all over 24. Very, very easy and then simple. Let's look at exactly 1 head and a 1 or 2. So let's use the letter J to denote the event of obtaining exactly 1 head and a 1 or 2. So we have to list all the outcomes in this event. We are talking about 1 head and the number 1 or 2. So we have 1 head here, 1 head here. So we have 1 head and then the number 1 or 2. 1 head and then the number 1 or 2. So we are going to pick HT1, HT2, TH1 and then TH2. So all of this, so we have HT1, TH1, so we have HT2 and then TH2. So once we are done with this, we find the number of outcomes in this event. And that is 1, 2, 3, 4. So we have 4. So the probability of obtaining exactly 1 head and 1 or 2 is equal to number of outcomes in that event all over the total outcomes in the sample space. So we have 4 all over what? 24, and that is going to give us what? 1 all over 6. Very, very easy. Let's look at the probability of picking 2 tails and an even number. So with that, let's use the letter K to denote the event of picking or obtaining two tails and an even number. So we have our K. We find the set of possible outcomes in this event. So we are talking about two tails. So this is the two tails column and then even numbers. And we know that even numbers, they are numbers that are divisible by the number 2. So we can see this two tails and then the number 2, two tails and then the number 4, and then two tails and then the number 6. So we have TT2, TT3, and then TT6. So once we are done with this, we find the probability of obtaining two tails and an even number is equal to number of outcomes in that event. We have 1, 2, 3. So we have 3. We have 3 all over the total number of outcomes in the sample space, which is what, 24. We can break it down, right? 3 into 24, how many times? We have 1 all over 8. Very, very easy and then simple. I'll leave the last one for you to try your hands on it. 2 hairs and then a multiple of 3. So we have 2 hairs. So this is 2 hairs. And then a multiple of 3 means the 3 times table. So we have 3, 6, 9, 12, 15, and so on. So it's going to be HH3 and then HH6. So the probability of picking 2 hairs and a multiple of 3 is equal to, so we have 1 and then 2. So we have 2 all over 24, and that gives us 1 over 12. This brings us to the end of today's lesson. See you tomorrow. Bye-bye.